These are video solutions to the web assignment on concavity. So we'll go through this. I took the derivatives. Spend much time on that. So for the first one, the second derivative is just 2. When you're trying to figure out if it's concave up or concave down, you find the possible points of inflection, find out where this second derivative equals 0. Well, the second derivative never equals 0. That means this is always concave up or always concave down. So this is a strange one. Your test interval would be just from negative infinity to infinity. There's no place that it changes. And you can just test any number, f prime of 5, for instance. Since the second derivative is always positive, it's positive 2. This is positive. So this graph is always concave up. So we'll say concave up on negative infinity to infinity. And I don't like this terminology for concave down, does not exist, but the directions tell us to write that, so I did. Next one. The next one, the second derivative is 30 minus 6x. So that equals 0 when x equals 5. So we'll go over to our chart and find the second derivative, say at 0, that's in this interval. And then the second interval will pick something greater than 5. When you plug in 0 to the second derivative, you'll get 30, which is positive. When you plug in 6, you'll get 30 minus 36, which is negative. So it's concave up where the second derivative is positive, so negative infinity to 5, and concave down 5 to infinity. Next problem. Next problem, the derivative was a lot more complicated. Well, the second derivative was. The first derivative is a pretty simple chain rule. The second derivative, I use the product rule. I'm going to, if you should practice this derivative, just don't use mine. If you need, you can pause this video to kind of go over my work, or I'm also going to include a PDF file for you. But this is the second derivative, and I checked it on Wolfram Alpha. So the second derivative equals 0 when x equals plus or minus 1, because that's where the top equals 0. And if you look at the bottom's always positive because that's x squared plus 3. So the bottom doesn't ever go to 0. So on your chart, you're going to use the negative 1 and positive 1, where the second derivative equals 0. Your test points, negative 2 here, 0 here, and whatever, 5 here, anything greater than 1. So let's look at this one. You plug in negative 2 to this second derivative, you'll get, that would be negative. This would also be negative. So you have a negative times a negative, and the bottom's always positive. So it's a positive over positive, which is positive, concave up. When you plug in 0, you'll get a positive times a negative over a positive, which is a negative divided by a positive, which is negative, concave down. When you plug in 5, you get a positive times a positive up top over a positive on the bottom, positive. So it's concave up on negative infinity to negative 1, and then again from 1 to infinity. These intervals. It's concave down on this interval, which is negative 1 to 1. Next problem, number 4. Same question. I went to Wolfram Alpha to get this derivative. I typed in second derivative, and then I had to scroll down to get the alternate form, the factored form, which is this. So that's my second derivative. The top never equals 0, obviously. The bottom does equal 0 when x equals -1/5. But that you can see is a vertical asymptote. So you still have to include that in your chart. And if you've been practicing these, you'll remember that for the vertical asymptote, we should write as a vertical asymptote. So in the first interval, I'm going to determine my second derivative at something less than -1/5. So let's just say -100. Next interval, something greater than -1/5. The easiest thing to do there is 0. If you plug in -100 to the second derivative, notice that second derivative is negative. You'll get a -410 over some negative number to the third, which is definitely negative. So you get a -410 over a negative number, which is positive, concave up. You plug in 0, you'll get a -410 over a positive number. So negative over positive is negative, concave down. So it's concave up from -infinity to -1/5, and then concave down from -1/5 to positive infinity. Next question. Now we're looking for the points of inflection. So we're going to do the same thing, but when we get the second derivative, if we find out that it changes signs, we're going to call that the x value of the point of inflection. So I took the second derivative for you. It has a possible point of inflection at 3. So the second derivative at 0 is going to be negative. 6 times a -3. Second derivative at, say, 5 is going to be positive 6 times 2. So it did change concavity right here. Went from concave down, -infinity to 3. Concave up, 3 to infinity, which means 3 is the x value of a point of inflection. So I'm going to write that right here. And the y value is you have to plug 3 into that function. I'm going to quickly do that on a calculator. 3 minus 9 times 9 thirds 9 times 9 plus 22 times 3 minus 12. I got 0. Okay. So check me on that, but let's go on to the next one. The next one, same question, but the second derivative is this. So the place where the second derivative equals 0 is only at x equals 0. I'm going to plug in the second derivative at, say, -1, and the second derivative at +1. And you can see from the second derivative, it's a -48x squared. That's always going to be negative. So it's actually never concave up. It's concave down from -infinity to 0, and then from 0 to infinity. So it's concave down the whole way. That also means there's no point of inflection because it did not change concavity. So that's that question. Finally, the last question is a trig question. So they limit your domain from 0 to 2 pi. So we're going to stay on one rotation of the unit circle. The second derivative of this function is -4 cosine x. And on 0 to pi, cosine of x is 0, where x equals 0, which means right here and right here, which means pi over 2, 3 pi over 2. So those are the two possible points of inflection. Remember, we're starting at 0 and we're ending at 2 pi, not negative infinity to positive infinity as usual, because they tell us that's our domain. So in this first interval, I'm going to use, you can use 0 if you want, because that's not a possible point of inflection. So let's do it. Let's use 0. The cosine of 0, the second derivative, we know is 1. So it's negative 4 times 1, which is negative. The next interval, I'm going to use pi, which is right here. The cosine of pi is negative 1. Negative 4 times a negative 1 is positive 4, so that's positive. And finally, the last interval, I'm going to use 2 pi. And 2 pi is the same location as 0, so we're going to have the same result as 0, which is negative. So the conclusion is this. It's concave up from pi over 2 to 3 pi over 2. Concave down from 0 to pi over 2. And then again from 3 pi over 2 to 2 pi. And that makes our points of inflection pi over 2, comma, the y value, and 3 pi over 2, comma, the y value. Now to get the y value, you plug in put your x values into this original function. So remember, the cosine of pi over 2 and the cosine of 3 pi over 2 are 0. So that makes this kind of easy. When you plug pi over 2 into the equation, you'll get pi over 2 plus 0. And when you plug in 3 pi over 2 to the equation, you'll get 3 pi over 2 plus 0. And there you have it. Hopefully everything was right. If you see anything wrong, let me know about it, and I'll let everybody else know. The end.